Hey guys, Basic Circuits Part 2. Yeah, I know, it's more math. I'm going to make a separate video of like working some math stuff and upload it, because you're going to have a sheet doing this. So, let's go. Right, parallel circuits. We're dealing with parallel circuits. There is multiple branches of them. Now, remember back when we were talking series circuits, last video I did, I'll put a link in here, there was only one path, and the amperage was the same at any point in the circuit. And then the voltage drops across the series circuits were different at each load in the series circuit. Parallel circuits are a little different. The total amps is different at each branch. Okay, so I'll have a certain amount of amperage, traveling through this one, a certain amount traveling through this one, a different amount traveling through this one, and again a different amount traveling through this branch. Now, it has total amperage if we add all these up, but the sum of all of these added up adds up to the total current. You get it? So in the series circuit, it's the same amps through the entire circuit. This one, each branch is different. In the series circuit, the voltage drops were different at each point in the circuit, whereas a parallel circuit, they're all the same. Get it? So in the series circuit, when we add up in order to find the total circuit resistance, we just add them up. We can't do that in a parallel circuit. The math gets a little more messy, but that's okay. It's really not bad math, okay? So I'm going to run through them. Anyways, yeah, and all the branches receive the same source voltage. Okay, so some things to remember. Current is lazy, so it's always going to, the most amount of amperage is going to take the path of least resistance. So this 3 guy down there is going to have the highest amount of amps. And I know my total circuit resistance is going to be lower than this. Okay? So looking at it, I can look at the lowest one and I kind of know some things. All right, and then parallel is kind of the opposite of series. In a series circuit, every time I add another load into the series circuit, the resistance goes up higher because we add them all up. But in a parallel circuit, every time I add another branch, it drops the resistance down. So if the resistance goes down, the amperage goes up. Get it? Remember the arrows? All right. All right. Calculating resistance. There is 2 ways to do this. There's the hard way, and that works on everything. And then there's the easy way that doesn't work everywhere. I'm going to run through both of them, but really I'd rather you concentrate on the harder way to do it, because then it works everywhere. We'll talk about it later. Anyways, so this is the hard way. And I call it the hard way. It's really not that hard. All right? We got to take it 2 at a time. So I'm going to start with, these top 2. And it's really easy. I just plug it into the formula. Okay? So it's 4 times 4 above 4 plus 4. And if we do the math out of it, 4 plus 4 is 8. Or 4 times 4 is 12. Right? 12? No, 16. No, 16. 4 times 4 is 16, and 4 plus 4 is 8. So I got 16 over 8. Okay, so that gives me 2 what? 2 ohms. And then I do the bottom 2, and I do it exactly the same way. I take, the 6 and the 3 down here and plug it into my formula. It's 6 times 3 divided by 6 plus 3. 6 times 3 is 18. 6 plus 3 is 9. And then I divide 18 over 9. That gives me 2. 2 what? 2 ohms. So these 2 branches are 2 ohms, and these 2 branches are 2 ohms. Get it? So now I'm going to plug those two in together. And then that gives me 2 times 2 is 4. 2 plus 2 is 4. 4 divided by 4, it gives me 1. 1 what? 1 ohm. Get it? 1 ohm. So what this does for me is I know my total circuit resistance is 1 ohm. Now back to Ohm's law, Math 101, back on the last video, we talked about this. 12 divided by 1 gives me 4. So I got 12 volts divided by 1 ohm, that gives me 12 amps. So this circuit right here, total draws 12 amps. Get it? Now, I know, I know my voltage drops across here are all going to be 12. This guy gets 12 volts, this guy gets 12 volts, this guy gets 12 volts, this guy gets 12 volts. Right? Right? All right. So, calculating the resistance in series, the easy way, okay? Now, because I know this is 12 volts, and this is 12 volts, and this is 12 volts, and this is 12 volts, all I got to do is just calculate out, I know how many ohms, I know how many volts, back to Math 101, I can figure out the amperage, okay? So if I know source voltage, and I know the ohms, I can calculate the amps. So let's do it. Okay, take this one down here. 12 volts divided by 3 ohms. This is the Ohm's law, gives me 4 amps. You know, I do 12 volts divided by 6 ohms gives me 2 amps. 12 volts divided by 4 ohms gives me 3 amps. Okay, but I got 2 of them, so that gives me 6 amps. Get it? And I can add them all up, you know, do the 4 plus 2 plus 6 and 6, right? That gives me 12 amps. And then I can calculate backwards and work out my total circuit resistance by just, you know, again, Ohm's law. I got 12 volts, because I know I got 12 volts, and I got 12 amps. Where did I get that number from? Well, that's from adding all these guys up. I can figure out 12 volts divided by 12 amps gives me what? 1 ohm. So I can do this either way. This is 2 different ways to do it. Get it? Get it? This is resistance total, or RT. Series parallel. These get a little funky. Okay? I'll run through it, but I'm kind of expecting having to explain this again in class. So, anyways, so we look at this one, and you can see there is, you know, the 6 ohm in series with these two that are in parallel. We okay? All right. So we have to break this down into separate parts in order to make this workable. So the easiest way to do this is, you know, break it down and then add them up. Here, let's give it a shot. So here, I'm figuring out these two together. I got a 3 ohm load and I got a 2 ohm load. And I just plug it back into my formula that I was just using. 2 times 3 divided by 2 plus 3. Well, 2 times 3 gives me 6. 2 plus 3 gives me 5. 6 divided by 5 gives me 1.2. Okay? 1.2 gives me, that's my total resistance of these two together. So I could easily redraw this as just being a simple series circuit. Get it? I've combined these two now. So then I, you know, can add in the plus 6 ohm, that's this guy over here, because it turns it into a simple series circuit, right? So I go 7.2. So 1.2 plus 6 ohms gives me 7.2 ohms. Got it? Now I can figure out the total amount of amperage on this guy. Okay, that's pretty easy to do. Ohm's law again, Math 101, 12 volts divided by 7.2 ohms gives me 1.67 amps. So the total amperage of this circuit is 1.67 amps. The total resistance of this circuit is 7.2 ohms. Got it? Now I could figure out pretty easily like what that 6 ohm resistor does. Okay? It's kind of used as a control device. It happens. It used to happen a lot in dash lights, you know. So we can use this 6 ohm resistor to control the amperage in the circuit. So let's see what happens if we take that amperage. What happens to our amperage if we take this 6 ohm resistor out? Well, what it becomes is it becomes a simple parallel circuit. Remember, we took this one out. So I do it again, right? Same thing. I get 1.2 ohms. Well, that would be 10 amps. So it goes from being, you know, a very small amount of amperage with this guy in it, with this limiting resistor in there, or this limiting, and we could use another bulb. That would work. You know, but it's almost 10 times the current without it. Get it? All right. We're going to be doing this math. I'm going to show you how to do this math. We're going to be doing the first couple of problems in class. So this is just the primer. Okay? So we're going to look at some real stuff when we get in class.